So first of all, adapting to teaching for addressing misconceptions in physics. And I would like to start with the quote, adaptive teaching is less likely to be valuable if it causes the teacher to artificially create distinct tasks for different groups of people or to set lower expectations for particular peoples. Now when we talk about misconceptions, they are there in different subjects, and for example in science there are loads of misconceptions that we have, and even though we try to remove those misconceptions, but they are still there. For example, if I have these 3 pens and this piece of paper, what do you think is going to fall first on the ground? The pen, right? So you can know that it's going to fall, right? But if I've got this pen over here and 3 pens, which is going to fall on the ground first? 3 pens. Now, this is the common misconception. If you see over here, they fall at exactly same time, right? Now, again, if I use the same piece of paper and if I just, scratch it, what do you think is going to fall faster?
Depends.
Okay, let's see again. They fall at exactly same time. Now, because of our everyday life, we think that the feather actually falls down very quick, like slowly compared to the heavier objects. But this is not the true nature of gravity. Gravity has its own ways of actually dealing with the things, and it is because the paper fell down very slowly because of the air resistance. So if we take air out from the equation, for example, if we do the experiment on Mars or for example on Moon, where there is no atmosphere, the paper and the pen are going to fall at the very same time. Now this is one of the misconceptions, and even though if I teach in GCSEs to do the demonstration and if the same students come in A levels, if I ask the same question, they still say that the pens are going to fall faster. So these are the things that are, these are the misconceptions that are still there, right? Now, misconceptions in physics are, if we go to the next slide, the misconceptions in physics are common and can significantly hinder learning, because if you don't know the fundamentals of how the things are working, then it becomes very, very difficult for us to actually get through, the basic knowledge. Now, these are deeply rooted and incorrect understanding of physical concepts that students often bring to the classroom. So again, as I said, from the early childhood, we have this perception in our mind that the heavier object is going to fall faster, but in reality, it is not the case. And in the topics in physics includes Newton's laws, electricity, and energy conservation. These are the topics in which the students find it very challenging to actually know the concepts right. Now, how do we identify misconceptions, especially in science lessons? So first of all, we have got diagnostic assessment. So use pre-test and formative assessment to identify misconceptions. Analyze common incorrect responses to understand where the students struggle. So basically we give them worksheet, for example, and it has some questions. And by looking at the responses, we can see the students have what sort of misconceptions are there and what needs to be addressed. And it depends on the classroom. For example, if there's a mixed ability students, you will be able to see that there are loads of more misconceptions compared to those who are high ability. Now, and also like during those worksheets, we can observe classes. For example, I observe the classes and I can interact with the peers, and so that I can know what are their responses and where are the lack of understanding. Now, if you go to the next slide, there are 7 questions, and we know all about energy. Now, my question is, you can just participate in that. It says, how many of these statements are true? So there are 7 statements. You can just read through all these statements, and then you can just raise your fingers. If you think only one statement is true, you can raise one finger. Otherwise, depending upon how many statements you are thinking are true, you can raise that many fingers. So I just give you 2 minutes to read all those 7 statements, and based on your knowledge, can you please show your fingers to explain how many statements could be true? Here's if everyone ready. Okay, 2, 4, okay, 5, 1. So in reality, none of these statements are correct. All of them are false. So in physics, for example, the concept of energy is very difficult, to be honest. Like we talk about energy, but energy, Richard Friedman said that energy is a quantity in physics that we can calculate, but we can't explain it. That what is energy actually is. We know that electrons move in the wire, but where the energy is stored. So energy is not an object that is basically stored. Similarly, this pen, for example, if I have at a certain height, obviously it has gravitational potential energy. But if I just place it on the bench, relative to the bench, it has 0 gravitational potential energy because it can't do anything. But if I just make it slightly fall down, obviously the energy that was there in the gravitational store can be converted to kinetic store. So the concept of energy is very difficult to get it right, and these are some of the misconceptions that we have in everyday life. Now, the strategies that we use is like targeted instructions. So depending upon who got it wrong, maybe there are some students who have got it right and there are some students who have got it completely wrong. We can have discussion with those students and actually explain what is the basic science behind them. Interactive simulations, peer interactions, and then obviously scaffolded learning. Now, if you see on the next slide, this one again, this was from the PowerPoint. There was a famous experiment performed by a physicist Rex Brown. Basically, what he did was he went to a NASA facility and he actually removed the air. So you can see the feather ball and the cannonball, and the misconception is that both the cannonball has to fall faster. But in the actual experiment, when they did the ball and the feather, it fell actually at the same time. So these kind of experiments and these kinds of animations, for example, or the videos can actually help them understanding better. And then again, benefits of adaptive teachings are improved understanding. Obviously, we can actually show them in reality what is the true nature of science, increase engagement, and enhance performance. And again, this is not only limited to science only. The misconceptions are there in every kind of fields and subjects. So again, depending upon what subject you teach, there could be some misconceptions that you can actually, address depending upon your class. So that's it from my side. If you have any questions, please let me know. I'm happy to address that.